Well, hello everyone. I have finished my attempt to rebuild build a one-chip radio based on this little AKC 4926 chip that I found in a very cruddy pocket radio that I purchased at the thrift store. And my goal in this project was first to see if I could understand what was going on with the original radio, which I kind of got right in the very haphazard schematic that you can see underneath the radio here. That's mostly correct. I didn't quite understand how the band switch works, and there really isn't a band switch. And the reason why I didn't understand that is that there really isn't a band switch needed when this is implemented as an AM/FM radio. So the band switch can effectively be replaced by a couple of resistors, and as you can see, the AM/FM switch would be sufficient, and that's the AM/FM switch. So what I've done is implement the circuit that was in the data sheet for the chip. And let me just slide that over here. Okay, so there's the thing, and here's the data sheet. So this is really a fairly straightforward circuit, because really it's just a bunch of control electronics and in and outs for the chip itself. So let me point out a couple of things here, and then I will sort of slide over the board. I'm going to unplug the batteries. I did put a different speaker on this, which weighs about as much as the whole radio, including the batteries in total. So it's a bit like you can't just pick it up quite the way I used to before as I was working on it, but it does actually have understandable sound now. Okay, so let me explain how this works. This block here, this is the band switch. And effectively, if you only want to use it as an AM/FM wire, you only need to connect to here and to here. And then you need a resistor to make up the rest of this. And that's the approach that was taken in the pocket radio that I took apart. That's essentially what they did. The ends of these two here, what would be the switches, then go to the, one goes to the, one end goes around and goes to the AM switch, and one goes into the FM switch, right? And that's these that come around here, FM, AM. The rest goes into a 5K potentiometer here, which is the tuning, and then there's another 5K potentiometer. I'm sorry, 50K potentiometer that provides the volume control. So the volume control is in fact digital, controlled inside the chip. There's no analog volume control on this. In fact, there's nothing analog on this at all. So if we look at this on the circuit board, this represents the band switch. So that represents all the potential spots here. And these two switching elements are represented by these two jumper wires. And so it's just my solution to that. And there you see 16 10K resistors that make up the sort of resistor ladder that forms the band switch. Here are our two 50K potentiometers. The top one is tuning. The bottom one is the volume control. And you'll notice I've used yellow wires to represent the sort of control circuitry on here. You know, black for ground, red for power. I'm using green for antenna connections, and blue is the audio out. I've essentially done a ground plane along here and here of the board. So that's how it works. It looks more complicated over here than it is. It's very straightforward. What is particularly clever is this, which is this switch here that switches, I'm sorry, that's the crystal. These switches here that switch between AM and FM. What they've done is they've managed to use two pins for two purposes. One, they provide for LEDs over here to indicate which position it's in. And they also provide for the signal wire to tell the chip whether it should be in AM or FM mode, which is kind of neat. They save themselves two pins on it. And they do this here by having you essentially short out to ground the LED of the appropriate signal wire, and it then lights the opposite LED is then lit because that one's grounded out. And presumably it's just looking for the voltage drop of the LED on the side. I've used two. That green one is an old-fashioned, what are they, gallium nitride LED. So the voltage drop is probably quite a bit different from these two. It was probably a poor choice, but that's what I pulled out of my box, and it seems to work just fine. So that's this part implemented. That's this part. Here's the FM antenna coming in. I should say on the original radio there were no LEDs implemented to show FM and AM, and nor this one, which is the tuning LED. They'd in fact just implemented a single LED on the power switch to tell you that it was on, which, you know, if they could have put the tuning LED on, that would have been more useful for, you know, I think they would have needed one less resistor to do that. So here's the antenna coming in. It's got a set of diodes which are intended to presumably shunt transients like static electricity to ground. That wasn't put in on the pocket radio. It did have the 3 nanofarad capacitor here, and that goes into this pin 20 here, and I've implemented that. That goes out. There's the diodes. That's the ground plane there. And then that comes over here with this little green wire. There are our 3 1 nanofarad capacitors, and that then goes out to this green wire here, which is the FM antenna. For the AM, there's a ground pin here for the chip that has no capacitors on it at all. These two pins here, I've gone in underneath to do them, but they come in and come out in these two spots here. I was originally going to put the ferrite bar in here, but it picked up noise, presumably from all these signal wires that run along here. So I ended up just hot gluing it to the outside, and then that goes to the ferrite antenna, and that provides the AM antenna. Yeah, the next two are the control pins. Yeah, well, what else is worth showing? So here's the crystal. That goes between, the crystal is right here, and that's represented by here. And that just goes, hopefully you can see that. That just goes here, and then the two pins and a couple of capacitors that, connected to ground there. What else do we have? This is a power in pin that goes in through some filtering capacitors. Audio out goes out, has a single filter capacitor on one lead, and then runs up here to the speaker. This is a 4-ohm speaker. I think it actually specifies an 8-ohm speaker, but it's working fine. I don't think there's much else to talk about here. It's a fairly straightforward. It's just a few control circuits, antenna leads, and this thing is just looks complicated, but it really isn't. It's very straightforward. And in fact, this shows some possible. I'll just lift up this so I can slide this under. That shows some possible modes, but this shows, all the various modes you can get by switching any of these. And then there's a chart which indicates, which radio mode it would be when it's set for each of those levels. And that corresponds perfectly to what I've got along here. So you can set, with this setup, you can use any mode that the chip has available, and it's got, you know, some FM modes. So this would be like Asian FM mode, 70 to 9, or lower at 70 to 93 FM mode, and then this would be, you know, our normal North American FM mode. Right, so there are a number of this potentially has long wave on it. So we'll see if that works. I suppose there's no long wave signals really to hear anymore. They've shut off the Pearson Airport signal, I believe, so there's not really anything to listen to on long wave in central Canada. Yeah, and then these modes down here are essentially the shortwave bands. And so that all can be controlled by adjusting these two jumpers to whatever level you want. A couple of things I found out while building this. Because of course you have this big resistor ladder, it's very sensitive to, you know, being built on a breadboard as I originally did it, and, you know, wiggly, tiny little resistor leads being stuffed into breadboard slots don't lead to very consistent you know, resistance measurements, because of course the chip is effectively taking resistant measurement, you know, however many times a second over there. I also found that I originally tried using nonlinear potentiometers because I had some nice big knobs of volume control types in 50K, and that was very, very difficult to do anything with, and they were wiggling around on the board. So I just used these little screw ones. Obviously, in a real radio, you would need something better. I suppose I could reuse the ones from the original radio if I was trying to do something with this, as opposed to just building a demonstration. And that was useful. Interestingly enough, although I made several mistakes as I was building this that had to be fixed as I was doing so, I caught them, and it worked on the first try, which it did on the breadboard too, which I was kind of shocked. So I guess yay for me about that. I think I learned a lot in terms of understanding how the logic of controlling this works, and I think I've seen it in other people's discussions of other, you know, sort of similar kinds of projects online. So I think I've learned a lot. The hardest thing I found was desoldering and soldering on this surface mount chip. I busted up the board. I took it off of pretty badly getting it desoldered, which meant that the pins weren't perfectly lined up when I tried to solder it back onto this little board. This little board's great, by the way, and on the other side it has it has a provision for soldering on a pin with wider pin spacing than this very fine one. So you get like two uses out of the same board, which is great. I guess if you're getting them made up double-sided, it doesn't matter anyway. But yeah, so that was difficult. So then I had to go through, and I did have some of these pins got bridged, and the only solution I had to that was to muck about with an X-Acto knife and try to separate any traces. So I think that's enough said. I'm going to pause this and get out a screwdriver so I can adjust it. I'll demonstrate FM and AM, and then I'm going to try a little bit of daytime shortwave and see if I can luck out and get something on it. I did pick out this little XH data, which I mentioned previously as I was talking about my interest in this project, and there are a couple of fairly strong stations around, so maybe I'll have some luck. I still have had a little bit of trouble. I think I've got some shortwave on it before, but not so sure. So let me get the batteries and a screwdriver. We'll demonstrate FM and AM briefly, and then we'll try shortwave. Okay, well, I have acquired a screwdriver. I've plugged in the battery box, so let's see what we've got. So let me just get the microphone in so that you can hear it a little bit. So we can move. Of course, there's a ton of interference around here with the computer that's in the background on my desk. But as you can see, or here I suppose, it's a fairly decent FM radio. It isn't very good at getting rid of interference, but it does work. So now I will switch it over to AM and see if I can find some AM stations. It's a little touchier on AM. This ferrite is very small, and of course on AM all those sources of interference are considerably more problematic. So this is French CBC from Toronto, usually the strongest AM station on the band.
And using that loop around ramp by the Wendy's and Tim Hortons, it's going to be hard. In action saying that vital information like that always finds a way through the filters up to the top of any organization. Batman was asked why that $2 million fine is less than what other teams.
So I'm pretty pleased with this. I think it's working really quite well as an AM/FM radio. Now, while we're in AM mode, it's possible to move it into shortwave mode, and I believe we want the band will want at this time of day. It's probably level 8 or level 7 on that. So that goes. So I think that's 10 down. Oops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as you can see, it's definitely changed bands. And obviously this is the extent of the antenna. There's not. But as you might have been able to hear there, it is on a different band and is definitely trying to receive something. So I'm going to hook up a longer antenna, and then I'm going to play with it off camera, and with a little luck, we'll have something here this afternoon. Well, so far no luck at an actual shortwave signal, but I have got some interference, and that can demonstrate a little bit. Well, the interference can demonstrate a little bit how the tuning works on this. So I will try to hold the mic down here, and hopefully you can hear me and it. I'm going to turn up the volume a little bit. Okay. So it's picked up some interference. And you'll hear about every third of a turn it moves a step. So that would be about 3 5 megahertz steps per turn. And so this gets fairly tedious. But it is possible to get through the band. click there was my furnace fan turning off, which you might have heard in the background. That's got a very variable frequency drive on it, which doesn't help matters either. Yeah, that doesn't appear to be a shortwave band. Anyway, well, the point is there's not too much more time mucking about with this. Maybe if we get a really good shortwave night, it'll be worth playing with again. Currently, a couple of things show up on daytime shortwave here in Toronto, but you know, the usual stuff from the U.S. I did want to show you the bottom of the board. Well, I was at it just to give you some idea of how I ran this along here as a ground plane, and this partially is a ground plane, and then unfortunately I have this wire that comes up around here. It would have been probably more sensible to try to run a ground plane all the way around the whole thing, I suppose, but I don't know. That's far beyond me. But you can see how each of the pins comes off, right, and then works up. These ones are a bit of a mess, but as I said, a little bit of care and it works just fine. And I have to say I do use lead-free solder because I've got a 5-year-old, and so I tolerate the irritation that entails. All right, well, I think that's where I'll wrap up this project. In my mind, this was a great success. It works. It works surprisingly well, and it's a perfectly workable AM/FM radio. It drives this little speaker quite well, and you can certainly see how someone could have built a good quality radio out of this instead of the junky one that I started with. There's nothing inherently wrong with the chip for that regard. My guess is it's not a very good shortwave radio anyway, and there may be something with me, the way I've got the antenna set up working, and comparing it to FM in downtown Toronto, well, these stations are so strong that one generally doesn't even need to put up the antenna on any radio to use it. It's fine. So, and this little piece of wire has been perfectly adequate for any local stations. Now it's all stuck underneath there. But yeah, so I think I will call it a day with this project, and hopefully you enjoyed hearing about it. And I really think it really taught me a lot about how these little things are put together, how we have an era of incredibly cheap DSP-based radios on the market. Lots of YouTubers talk about them and review them, and they perform amazingly well. And one chip, and very little in supporting hardware for that is required. Really, how much you spend on the speaker and on the case design is probably the most important part of how nicely these radios perform. And I think a better speaker, better case, well, then they get charging circuits and all that, right? As we can see with something like this XH Data, which has a flash card player at the top and a charging circuit for the battery in it. I really like this radio. This radio is great. I mean, it's cheap and cheerful, but it's really fun. So yeah, you can see where they're coming from. I did buy another portable radio within a couple of days of this one, and I bought it because, well, I wanted to see if it had the same chip in it, and it doesn't. It's got an analog chip in it, and I haven't really wanted to take that one apart because the tuner is, if I disassemble the tuner assembly, there will, you essentially, these little tiny radios, well, not this kind, but the little pocket radios have, let's see if I can draw it here. They have the tuner knob, and they have a little piece of flexible plastic, usually in bright red, that attaches to the tuner knob and then runs through a little slot to form the tuner. So, 88108, right? So that then forms the tuner, and that's what you see going through, and it works really well. But, if you disassemble it, you're never going to get it back together. That's done once you do that. So when I took the radio for this apart, I just clipped that right off there. Right, just cut it with side cutters, and so that will never happen again. I did want to say one more thing about the little radio that this came in. This radio is better than the one that this chip came out of because it's got a better speaker. That's it. Apart from that, and it's upgraded a bit, right? It's got LEDs, it's got a little bit bigger capacitor there, it's got the tuning LED. It's, if it had proper knobs, it would be a totally workable radio, and part of me does want to put it in a box and try to do that, but I have lots of radios, so there's not really much point. Well, it's just a sort of demonstration of the concept. Anyway, so with the other radio that has an analog tuner in, that then raises the idea of taking the analog tuner chip and seeing if I can build something similarly. And as I said, one of the problems is that if I take out the knob to the tuning condenser in that, I'm going to end up having to clip it, and there'll be no getting it in. It looks like the way that they calibrate these dials is they slide it in the first place, and they're presumably feeding it in a signal of some sort. They slide it into the right spot and then just hit it with a heat source, probably a soldering iron or something, and holds that in place. And that's the way this one was done. It was a pretty clever way of manufacturing it. The other problem with that radio is that I can't read the chip number. The chip number, there's some goop on it. I don't know if it's deliberately obscured or just sloppy manufacturing, which means that I would have to reverse engineer the circuit to try to figure it out. And of course, an analog radio circuit, even on essentially a single chip radio, is a lot more complex than that. So I'm not sure if that's a project I'm ready to take on right away. I do have some other new projects coming. So I'm very pleased with this. This was a lot of fun, and it will now go in the finished projects drawer unless I think of something else to do with it.